A peculiar square-shaped formation spotted on the Martian surface has ignited debates, curiosity, and a renewed passion for planetary exploration. Could this be a sign of life? In this video, we will break down the discovery, examine expert opinions, and explore why this formation is so intriguing. Stay tuned for a fascinating look at Mars' latest mystery. In a remarkable revelation, images from NASA's Mars Global Surveyor (MGS) have unveiled an almost perfect square-shaped structure on the Martian surface, measuring approximately 3 kilometers, 1.8 miles, in width. This geometric anomaly is located in a region known for its flat and relatively featureless terrain, making its distinctiveness even more striking. The MGS, which operated from 1997 until its final transmission in 2006, played a crucial role in mapping Mars' surface. Even years after the mission concluded, its vast archive continues to provide new insights. The emergence of this image has sparked widespread intrigue and speculation. High-profile figures have weighed in on the discussion, with SpaceX CEO Elon Musk advocating for a direct investigation. He suggested that sending astronauts to Mars to examine such anomalies firsthand could yield invaluable insights. The public's reaction has been a mix of excitement, curiosity, and skepticism, with social media buzzing with theories ranging from natural geological processes to the tantalizing possibility of artificial structures. While the idea of an artificial structure on Mars is captivating, the scientific community leans toward natural explanations for the square formation. Mars has a rich and complex geological history, with various processes that could lead to the creation of such geometric shapes. One plausible explanation is tectonic activity. Evidence suggests that Mars has experienced tectonic forces capable of creating fractures and faults in the crust. Over time, these linear features can intersect, forming polygonal patterns including squares. The Cerberus fossae, a series of semi-parallel fissures on Mars, exemplifies how tectonic activity can produce striking linear formations. Erosion also plays a key role in shaping the Martian landscape. Wind erosion, driven by Mars' thin atmosphere, can wear down rock surfaces, accentuating existing fractures and enhancing angular features. Additionally, volcanic activity can create lava flows that cool and contract, resulting in polygonal cracking patterns. Similar processes observed in different regions of Mars demonstrate how naturally occurring formations can appear artificially geometric. A fascinating aspect of human perception is our tendency to recognize familiar patterns in random stimuli, a phenomenon known as pareidolia. This cognitive bias often leads us to see recognizable shapes, such as faces or geometric figures, where none actually exist. A well-known example is the face on Mars, a rock formation in the Cydonia region that, under certain lighting conditions, resembled a human face. However, later high-resolution imaging revealed it to be a natural mesa, illustrating how light and shadows can deceive the human eye. Comparing Martian formations to Earth's geology further supports natural explanations. For example, Northern Ireland's Giant's Causeway consists of thousands of interlocking basalt columns, primarily hexagonal in shape. These formations resulted from volcanic activity, where rapidly cooling lava caused contraction and fracturing into geometric patterns. Similar natural processes could explain the square formation observed on Mars. Discoveries like this continue to fuel discussions about the possibility of past life or even ancient civilizations on Mars. While the prevailing scientific consensus attributes such formations to natural geological processes, the allure of uncovering evidence of extraterrestrial life remains strong. Investigating these anomalies directly presents significant challenges. Sending crewed missions to Mars involves overcoming obstacles related to cost, technology, and human health. The journey itself is lengthy, exposing astronauts to prolonged periods of microgravity and high levels of radiation. Additionally, developing life support systems capable of sustaining human crews for extended durations, along with ensuring safe landing and return, remains a formidable task. Human exploration presents formidable challenges, yet the potential rewards are immense. Astronauts possess the unique ability to conduct real-time analyses, make intuitive decisions, and adapt to unforeseen circumstances in ways that current robotic missions cannot. Their capacity to closely examine geological formations, collect diverse samples, and deploy advanced instrumentation could offer groundbreaking insights into Mars's history and its potential to support life. Balancing scientific skepticism with the excitement of discovery is crucial. While a critical approach to new findings is essential, maintaining a sense of wonder fuels innovation and exploration. The recently observed square formation, regardless of its origin, has sparked discussions about planetary geology, the possibility of extraterrestrial life, and the future of space exploration. Mars has long presented enigmatic formations that ignite debate and fuel human imagination. Beyond the square structure, scientists have observed other remarkable features across the Martian surface. In regions such as the Tharsis and Eridania quadrangles, researchers have identified magnetic stripes embedded within the planet's crust. These stripes, first detected by the Mars Global Surveyor's magnetometer, are approximately 100 kilometers wide and extend up to 2,000 kilometers in parallel bands of alternating polarity. Similar to the magnetic striping found on Earth's ocean floors, which provided crucial evidence for plate tectonics, these Martian formations suggest that the planet once had a far more dynamic crust than previously believed. In 2022, NASA's Curiosity rover captured an image of a rectangular rock formation resembling a doorway, leading to speculation about underground structures or even artificial entrances. However, further analysis confirmed that this feature was merely a small fracture in sedimentary rock, naturally formed through erosion and geological shifts over time. The scale of the formation, measuring only a few centimeters across, quickly dispelled any notion of it being a significant structure. Perhaps the most famous case of pareidolia on Mars is the Face on Mars, an image captured by Viking 1 in 1976. At first glance, the formation appeared to resemble a massive humanoid face, fueling speculation about ancient Martian civilizations. However, later high-resolution images from the Mars Reconnaissance Orbiter and Mars Express revealed that it was simply a naturally eroded mesa, with shadows creating the illusion of facial features. Thank you for watching. If you enjoyed this video, be sure to like, subscribe, and hit the notification bell so you don't miss out on more exciting space discoveries. Until next time, keep looking up at the stars. Who knows what new mysteries we'll uncover next?